And now I'd like to introduce Dr. Kim Stansfleld. Dr. Kim Stansfleld became the... Yes?
Yeah.
Hello. He became the second UK recipient of the ACAO Prize in 2016 for his outstanding contribution to the advancement of quality function deployment, QFD. Following bachelor's, master's, and PhD degrees in materials science and technology, he moved to work at his PhD sponsors, the Composite Materials Group of the UK's Royal Aerospace Establishment, before moving to Lucas Engineering and Systems in 1990 to work on development of a quality-assured, automated design and manufacturing system for complex aerospace composite components. Here he learned how to apply Japanese TQM methods, including classic QFD, to complex system design.
Thank you. Can everybody hear me?
I can hear you.
Great. I will, okay, screen share. Let's just bring up. Okay, let's make sure that's the one. Just going to share the presentation and then we'll get going. So, yeah, so I'd also like to extend my thanks to the International Academy for Quality's Quality in Education think tank team, including Cameron and Matt, for inviting me to talk. I'll explain shortly which area of the IAQ I currently work in, and a little more about my background, which might give some context for the presentation focus today. So as I say, I'm going to talk very, very briefly about QFD, give some context for a project I'm going to talk about. Whilst I was working at Warwick University, working on virtual reality, mixed reality, and its application to apprentice degree programs, sponsored part-time apprentice degree programs. I'll then start to look at some of the quality assurance methods that QFD brings that provided context for the project, particularly structuring of the higher education enterprise strategy and how that deploys to give the context for innovation within education. I'll then look briefly at the identification of stakeholders and needs. We will then move on, and I'll do a short video showing the actual measurement work that we did as part of the virtual and mixed reality trial in engineering, the case study. And then very briefly, I'll link it all together and bring some conclusions. So my background very quickly starts top left. It repeats what Matt has already said about coming out of Farnborough, moving into the Bright URAM European collaboration project to develop automated composites manufacturing, specifically for complex components at Lucas Engineering and Systems. And they were studying what are the Japanese immigrant companies from Toyota, Nissan, Honda, teaching us about what we need to do to compete with their supply base. We were primarily automotive and aerospace suppliers. So we were working on composite structures for V-22 Boeing, V-22 vertical takeoff aircraft, and helicopter components, etc., etc. From there, I moved into automotive telematics integration within the Advanced Engineering Center at Lucas. From there, I moved into what had become TRW's Tech Center, working on integrated vehicle control systems. What happens when you bring together brake, steering, and suspension, which was the culmination of probably 10 years of development on intelligent driver support, self-steering cars. But this one focusing on collision avoidance. From there, I moved into Northrop Grumman's enterprise systems. Throughout this whole process, I should say, I'm learning how to apply QFD and TQM methods to understand how to design things in a quality assured manner. This carried on within enterprise systems. From there, I moved into sustainable energy systems at the UK's Energy Technologies Institute, before in 2016 becoming the associate, well, initially as a senior teaching fellow in the applied engineering program, which I'll talk about because that's where I did the project with colleagues from Warwick, and eventually becoming an associate professor of transformational systems engineering. I took voluntary redundancy at the end of 2020. Many of the programs had come to a halt with COVID, and more recently been setting up my Vocate, voice of the customer across the ecosystems business. Anyway, part of the reason I'm talking today is because I was privileged to be invited to become an associate of the IAQ at the end of 2021, where I've been working with the Voice of the Customer think tank, and I'll carry on to that. And this is the Voice of the Customer think tank. So it's chaired by Glenn Mazer, Anil Sachev down at bottom left, and then Dr. Catherine Chan from Hong Kong, bottom right. And hopefully they're listening. So very quickly, from a QFD point of view, Matthew mentioned I was awarded the Akao Prize. Yoji Akao, I had the pleasure of meeting in 2010. Worked with Professor Shigeru Mitsuno in Japan to try and move some of the learning and lessons learned from TQM, working with Edwards Deming and primarily the American-led team that had gone to Japan in the 60s, late 50s and 60s. But how do we apply that in the design process? How do we bring it right up front so that rather than trying to fix problems downstream, we design the right system, the right product at the front end? So we have these two strands as well. There's a second strand that Yoji Akao brought, which was what he called the Hoshin Kanri policy management, deploying the vision of an organization as described in a series of goals, a small number of organizational goals, down through the organization so we get alignment vertically within the organization. So QFD is taking voice of the customer left to right across cross-functional management, across the different departments, making sure everybody's clear on what quality means. And then we have the policy deployment bringing from on high, what is this organization trying to do? What's the voice of our business or the voice of our enterprise? So what I did as part of this project is to try and apply these methods so that we could understand the context of the innovation we were looking at. And this is a summary of what Professor Akao and Shigeru Mitsuno applied. So basically this whole strand, which I've been applying for the last 32 years, really, since I learned about it, is to design positive quality in. It's not focusing so much on testing poor quality out. It's trying to prevent getting to a point where we need to test poor quality out or test defects out. So why do we do that? In summary, because as we see in this, when Ford took a controlling stake in Mazda, they noticed that there was this significant difference in the number of changes going on during the design, development, manufacturing process. So the blue curve represents Ford's change profile, typical profile for developing a car, where at production start, there's typically a drop in the number of changes. And then after product introduction, a lot of recalls and such like to try and correct the defects that have got through to the customer. The Mazda approach on the left with the red was really about understanding, using QFD, how to capture and do as many iterations to find out what's the real need and what's the design solution that best meets that. But across the whole product development time frame, so that we don't get to a product design which cannot be manufactured. So this is all about integrating the different business functions to ensure high quality comes out. The consequence of taking this approach, and this is exactly what was seen at Toyota, who really pioneered use of QFD between 78 and 84, was to radically reduce the time frame for development, to be able to radically reduce the cost of the development cycle, so that you could introduce a product that was actually attracting customers, was much more attractive. So the cost profile I've just put up shows the cost of change as you go through the development life cycle. And as you see, it goes absolutely exponential. The further we get through and get into manufacturing change, very, very expensive. And then, of course, it actually becomes really damaging to a company to have to do product recalls, etc. Okay, so the big development I've been involved in since 2010 is the development of the QFD standard for modern QFD, which is really focused on agile development, which is really about a more systematic way of analyzing and structuring business and customer needs and translating it through into, rapidly translating it through into the critical to quality requirements that customers expect. So 8-part standard, the final part, part 7, QFD for digitalized products, is just about to be published. So the development of this standard has been chaired by Glenn Mazer. I've been the UK rep, and there have been a number of other significant contributors from Germany and various other countries around the world. So context for the project, the virtual reality and mixed reality project, run in 2017, was I was not long working at Warwick University. My professor, head of department, Professor Steve Maggs, walked into the office one day and said, we've been given a grant to invest in apprenticeship degree enhancements, innovations. What do we think? And my proposal was virtual reality, mixed reality study, that we should invest in that and start to structure a study. Now, Warwick, WMG, what had been called Warwick Manufacturing Group, had been set up 40 years previously by the then head of the department, Professor Lord Bhattacharya. Sadly, he died in 2019, to focus on R&D and education for manufacturing businesses. It's now the largest department at Warwick University, or this certainly is the case back in 2017, when there were about 700 lecturing staff, many like myself who'd come out of industry. And it was rebranded as WMG to reflect higher education needs of service-based business as well as manufacturing. And the program that I got involved in originally was really focused on apprentice engineer degree program. It's pioneering program at the time, sponsored by Jaguar Land Rover and Network Rail and a few other companies in the transport sector. Subsequently, I went on to lead the master's program sponsored by GE Aviation, GE Power Systems, so global profile companies, which was an MSc in systems engineering technical leadership, trying to help engineers, senior engineers, learn about how to bring about systems level programs. And as I say, the AEP program, pioneering at the time, and it's really provided almost a framework for the UK's apprenticeship degree programs. The MSc program I was running was an MSc systems apprenticeship. So it's all part of industrial sponsored education. The background and the previous presentation gave an excellent intro to this, and actually the lectures that were brought forward last Friday, further excellent background to what I've got here, so I'm not going to stay on them, but there's this balancing act going on between massification in education with massive open online courses, but at the same time looking for personalization in education with things like role play, gamification. And of course, what we see is that the emerging technologies such as virtual reality, mixed reality, potentially support both of these strategies. So it has potential across a number of aspects of different ways you can deploy education. And it's recognizing as well that unlike some of the lecturing staff like myself, current generation's students are digital natives. I've got friends who've only ever known the digital world as the context they work and play in. And so the question for us is which are the technologies that support technology enhanced learning to focus on, and what's needed to deploy them, and an increasing need to blend workplace and higher education teaching facilities. So this was the thing in my mind at the time, was virtual reality offers that opportunity to do long distance but more personalized engagement with students who might be working in a virtual classroom at their workplace. So sorry about this, I should have put my phone on the... Oh, come on. Sorry about that. That's my son ringing. So I'm going to run through very quickly some of the key messages out of the QFD framework. What are the outcomes and goals we're trying to support? We were sitting in a new initiative, the Applied Engineering Program, the Sponsored Apprenticeship Engineering Degree. So what outcomes and goals of the university as a whole are we trying to support in our department? And I'll show how you can use Hoshinkanri very, very quickly. I'm not going to dwell on it. I'm just going to throw some things up very quickly, show you the kind of thinking that we believe is critical to this. Which stakeholders are impacted by the introduction of the new technology enhanced learning? As we heard in the previous talk, you've got to understand these people and these groups, because otherwise we'll have a great idea that works brilliantly for the students, doesn't work for the sponsoring organization, doesn't work for the IT support group in your university, or maybe doesn't work for your lecturing staff, who, like me, might be a little bit grayer in the hair area or actually lack hair. So very quick example of how QFD can help you with understanding stakeholders and needs. And then, what we found out from evaluations, how will they satisfy the key requirements of those stakeholders? So looking at the deployment from on high, HE organization, vision and outcomes, deploying down into different departments. This is very much the Hoshinkanri model. When I showed the chart earlier, the triangle was upright and now it's on its side. So this is what we're trying to show here in this structure that comes from the modern QFD way of structuring goal deployment, the voice of the business. This is what this is all about. Understand the voice of your business. What are they trying to achieve at a strategic level, and how can we quality assure the way we set our goals and follow our goals, innovate within our goals to achieve better performance, a higher quality outcome overall. And these then deploy down into department goals, and group project goals. So in terms of identifying stakeholders, one of the things I've brought to the ISO standards 16355 team was experience coming out of being a business process architect in one of my roles within an enterprise systems company, where we were using methods like SIPOC, supplier input, process output, customers. So all I've done here is I've captured a few. This is a subset of the SIPOC involved in looking at higher education apprenticeship degree teaching. So starting from the customer at the right, defining the customer, working out what outputs they need, which processes produce those outputs, what are the inputs, and what are the suppliers, and then capturing that information, having mapped it, to then properly lay out, so who are the stakeholders, what are their primary involvement and interests, what are their commitments or challenges that they have. And then another method that comes out in the modern QFD framework is to understand the link between the goals of your organization or your department, or for a program, and who are the stakeholders that impact those goals, as in impact successful achievement of goals. So this is just an extract again of a customer segmentation table, understanding who are the priority stakeholders to focus on when you do the data collection, recognizing throughout this, having been a program manager, the critical issue is to understand I have a finite resource and a finite amount of time. So if I spend too much time focusing the team on the wrong objectives or the wrong piece of technology, I will waste time, resource, which will not be given back to me and will be held against me in future. So I was bringing this thinking into the academic environment. I think we've been there before. No, this is just picking up, looking across the chain at the voice of the customer problems and needs. So one of the critical things that QFD tries to do, it understands the customer segment or the stakeholder segments, their characteristics, the situations, the problems they're facing, and the needs that they are trying to satisfy, potentially with the system you're looking at or the technology you're looking at. And based on Gemba visits, Gemba just means visit the crime scene or visit where the action's going on, visit lectures, understand what the lecturers are doing, understand what the IT support people are doing, understand what the students are doing. So by looking at these things, you create a picture of what's actually happening in the operation. Because too often you see technology development and deployment which does not work operationally. It works in a lab space, but not in the real world. And that is wasted resource. And being careful to listen and observe. Often what you are told is needed is not, by the customer, is not actually what they need. They'll often tell you what they think the answer is, or what they've seen that might be a solution. And also, these things are captured using a Gemba visit table that's analyzed and translated to a customer voice table. The important column here going across is coming to what's the stakeholder needs. And then using one of the modern QFD prioritization techniques, analytical hierarchy process, to really flash out. I'm doing such a short summary here, and I'm missing out major parts. I know that Glenn Mazer and Catherine, if they're listening, will be pulling their hair out, saying he's jumped across a huge chasm here. So I'm just trying to illustrate some key steps, guys. So please don't take this as a formal QFD message. And then focusing down on which solutions meet the needs, where you typically use a maximum value table to focus on the high priority needs. make sure you satisfy those high priority needs. Again, with that program manager hat on, I'd say be very careful not to waste your time on low priority needs at the expense of high priority needs. And then tabulating the pros and cons. This is the initial step, but then starting to build a better picture for what are the criteria we would use in an evaluation. At this point, we've come to a point where we're thinking actually the technology might be appropriate. These are the criteria we're going to use. So the criteria listed at the left, how they're measured, what's the current level, what's the target level, how are we going to test it? And this is how you then do a further analysis, affinity diagramming, to structure a hierarchy diagram to start to structure those characteristics to make sure you get clear and traceable level of criteria for the evaluation. So I think now we go straight into the case study. As I say, I was thinking either mixed reality or virtual reality. I didn't know which would be better. Colleagues working with me were, have we got time, Matt, for
5 minutes.
Yeah, so I might jump on. I was going to show the video, but yeah, so I've jumped on. I'm going to do the text bit very quickly. So this is what we were testing. So we initiated a test trial of virtual reality, mixed reality technologies, and with students, apprentice engineers from our applied engineering program curriculum, and Freya Asmat, one of my colleagues, and Devon Olcote were key people in that study, and hopefully they might be listening as well. But what we were looking at was student engagement and commitment in courses, the pedagogic outcomes, the knowledge, the awareness and skills transfer. And we were looking towards use in what was then planned as the degree apprenticeship centre, which has now been built. So we built some course content in virtual reality and mixed reality, looking at a solar panel. And these are the virtual models that we created. We were lucky to have the team with the skills to be able to do this, and then to properly evaluate them within a controlled environment. The students were taken out of a module that Freya was running on sustainable energy systems. And then in stage 2, we extended the process to investigate with other staff and students from Warwick University. Basically, we did a test and this was run by Devon Olcote, who was studying for her PhD, part-time PhD in interaction of human beings with computer systems, so psychology PhD. And students or people tested were given a test first. After a 10 minutes period of study, either with traditional teaching material, virtual reality or mixed reality, they were then given a further test, and the assessment was then made on how well they'd taken on board information, what they felt about the test. These are some test results that came about, and there's more detail here than I've got time to go into, but we're looking at different emotional learning outcomes, pedagogic outcomes. As I say, this is all down to Devon Olcote. I've got a reference there, bottom right, something that's published in 2021. And then we took the results and we integrated them back into the QFD process using Super Pew Matrix to prioritize them to understand the overall impact of the different technologies. And the results were really, virtual reality came out as best fit, mixed reality next, and traditional lecture technology third, in terms of a rational, a normalized percentage impact on critical characteristics. So fundamentally, the conclusions, Hoshin Canry, the deployment of policy and the management of policy gives you a quality assured way of deploying university outcomes and goals down into a department. Those are then used to evaluate different innovations that might be going on. They provide context and alignment for innovation within education. Modern QFD stakeholder identification helps you scope and focus innovation projects on key stakeholder needs. And these student trials of virtual reality confirmed VR and has greatest impact on engagement and learning outcomes, closely followed by mixed reality. Both were significantly better than traditional. Super Pew Matrix brings you back into allowing you to say, okay, this is a rational, systematic way of evaluating the different technologies. And what I'm suggesting here is the modern QFD integrated with systematic trial evaluations gives you a way of doing quality assured innovation framework for technology enhanced learning and higher education operations improvement. For references, I wrote a paper presented with Glenn Mazer and a number of other people from Warwick back in 2018. Devon worked on the analysis side and got that published in the Journal of Education Computing Research in 2021. And that focused on the trial aspects of the program. And then there are two references. There could have been a lot more on the QFD method and standards. And that's it. So thank you, people, for hanging on as I whiz through that. That's it.
Okay, thank you. Did you have a video you wanted to show?
I can do if we have time, because it just goes into.
How long is the video?
2 minutes.
I would say go ahead and show it.
Okay, thank you. Can we hear that?
Hi, I'm Dr. Stansfleld.
I can hear it.
UMG's applied engineering program.
This is from 2017.
How can we use this technology? One, to help us with the way we educate engineers, and two, to prepare those engineers for their future workplace.
Hi, I'm Dr. Priyasna, and I'm a Senior Teaching Fellow in WMG. As a part of technology-enhanced learning, I found augmented reality and virtual reality project quite catchy. This technology has got a lot of potential, especially in those cases when we can't afford expensive equipment or we don't have space to store the equipment. This technology can let us demonstrate the concepts without even buying them or without storing the equipment. My name is Devon Orkert, and I'm studying my doctorate here at the University of Warwick. This project is looking at how we can best utilize these technologies in education. We're using virtual reality and mixed reality technology and seeing what the pedagogic benefits of them are. Education is often behind industry when it comes to use of technology. We want the workers to be adept at using these technologies by the time they're in the office.
Hello, I'm Tim Hatchard. The focus of this project was to test the effectiveness of these programs with real students. We created the content in-house so it could be easily changed to fit module requirements. A solar panel simulation was created that allows students to change various factors affecting the power output.
Hi, my name is Jake Tinsley. The benefit within VR and AR is that we can recreate and duplicate equipment on the fly. This technology can reduce the cost of equipment in labs. Expensive equipment can be simulated in VR and AR. This technology allows students to comprehend and visualize complex problems. These simulations allow students to manipulate equipment they would not usually have access to. Our programs were created and modified to suit multiple headsets. We used the Microsoft HoloLens for the mixed reality experience and the HTC Vive and mobile phones for the virtual reality experience. The solar power simulations allow users to change parameters that would affect the overall power output of the cells. This includes the solar power type, tilt angle, the light intensity, mismatching, shading, and operating temperature.
Hi, my name is Emma Prescott. We began by creating basic models to represent expensive equipment for students to use in the digital world. Real-world physics were added, giving a sense of realism and immersion. With these applications, students can change the values affecting the equipment and see accurate results live. Preliminary results show that this increases students' motivation and engagement with learning materials. If we're able to increase student enjoyment, then this also helps to improve student satisfaction rates. Going forward, we hope to be able to further study our findings. Based on what we found already, we know that there are significant benefits to using this technology in education. There are significant pedagogy benefits, but also benefits for the lecturers themselves, potentially. Therefore, we wish to be able to run a longitudinal study to be able to see what the long-term effects of using these technologies are.
Okay. There we go. So, so as you saw, I'm still very much in contact and collaborating with Dr. Freya Asmat. Devon Alcott was recruited into the group I was working in at the end of her PhD. So she is now making rapid progress, bringing a psychology-orientated understanding to engineering education for apprentice engineers at Warwick. I was very fortunate. I was privileged to have such a capable team working around me at Warwick, who made a quick idea realistic. But for me, it provided a framework that allowed us to assess technology for technology enhanced learning and really for operation innovation within higher education, just as it had proved to do in so many other areas that I've worked in. That's it. Thank you.